everyone. Today in this class we are going to discuss about simplex method for minimization case. So I have taken one example. Let us see how we can solve a minimization case of simplex method. For maximization case we have already discussed. For maximization case you can refer the previous videos. So let us start the class. So I have taken one example here. Minimize z. The objective function minimization of z, that is x1 minus 3x2 plus 2x3 subject to the constraint 3x1 minus x2 plus 2x3, 2x1 plus 4x2 greater than or equal to minus 12 minus 4x1 plus 3x2 plus 8x3 less than or equal to 10. x1, x2, x3 should be greater than or equal to 0. As we all know, these all are variables and these variables should be greater than or equal to 0. So these are our constraint, this is our objective function. So first step is, the way we have done the maximization case, for minimization also we can solve it like that. But for this minimization case, we can also convert the minimization problem to a maximization problem and can solve it. We can solve the minimization problem as it is like our maximization. In case of maximization, we are considering the most positive number while entering the our table. For minimization case, we can take the most negative number, but that way we can solve it. The other way is that we can convert the minimization problem to a maximization problem, and as हम लोग जैसे किए थे सॉल्व किए थे maximization problem, that way also we can solve the minimization problem. So let us start how we can solve it by converting the minimization case to a maximization case and solve the problem. So let us start how we can do this one. We can write that maximize z dash is equal to minus of minimization z, or we can write minimize of minus z. So maximize z dash is equal to minimum of minus z dash. How we can convert the objective function here? We can convert the objective function like maximize z dash equal to minus x1 plus 3x2 plus 2 plus minus 2x3. Sorry, minus x1 plus 3x2 minus 2x3. We have done it. I am writing it once again here. Maximize z dash equal to minus x1 plus 3x2 minus 2x3. We have multiplied minus to this objective function to make it maximize z dash. Okay. Now how we are going to write the subject to constraint we have here. So how we can write it here? Like this is a less than equal to form, so we can go for adding a surplus variable here. So how we are writing this one? 3x1 minus x2 plus 2x3 plus s1 equal to 7. This case, this is a greater than equal to form. Okay, so we can convert it to less than equal to by multiplying minus minus for this side. How we can write? Like that we can write this one as minus 2x2 and multiplying minus here and here. So this will convert it to a less than equal to form, as we have minus minus sign will be here and this will convert to positive value. So minus 2x1 minus 4x2 is less than equal to, now we can write 12. Right? So this 2x1 plus 4x2 greater than equal to minus 12, we have converted to minus 2x1 minus 4x2 less than equal to 12. We have multiplied minus to both sides to convert it to less than equal to form. So how we can write it? This is converted to less than equal to form now. So we can write it like that, plus S2 equal to 12. Right? The next we can write it here, minus 4x1 plus 3x2 plus 8x3 plus S3 equal to 10. We have done with the constraints. Now we can put these variables to our, these are basic variables to the objective function. How we are going to write? This is minus x1 plus 3x2. We can write plus 0x1 plus 0x2 plus 0x3. As the cost, profit or cost, here we are considering the cost in the objective function we are considering is 0. This is done. How we are going to write this one? x1, x2, x3, s1, s2, s3 should be equal to, greater than equal to 0. This is our conversion of our objective function and the constant to equality form. Right? We have converted the constants into equality. Let's find the initial basic feasible solution. To get the initial basic feasible solution, this is our step 1 actually. Step 1. We have already discussed it actually. This is step 2. For step 2, we have to find the initial basic feasible solution. Initial basic feasible solution. So to get the initial basic feasible solution, we have to make x1, x2, x3 as 0. Let's assume x1, x2, x3 equal to 0. So what is the value of s1 now? s1 equal to 7, s2 equal to 12, s3 equal to 10. This is our initial basic feasible solution. Now we can go for the simplex table to do the solution, as whatever we have done for the maximization case, the same way only we need to solve it. So let us see how we are going to solve it. Let me draw the simplex step. So this is the initial basic feasible solution. We got it, s1 equal to 7, s2 equal to 12 and s3 equal to 10. After that, I have drawn the initial simplex table. How we have need to draw the simplex table? First, we have to write the coefficient of basic variables, that is CB. What is there? What is the value of C? The coefficient in our objective function. Basic variable. The basic variable, the coefficients. The coefficient of basic variable, that is S1, S2 and S3. As we all know, basic variables are s1, s2 and s3. Non-basic variables are x1, x2, x3, whatever in the constraints. So here the coefficients I have taken for from the objective function 0, 0 and 0. Then I have written all the variables. What we have in our objective function x1, x2, x3, s1, s2, s3. Let us write the coefficient of the objective function. The coefficients are like -1, this is 3, this one is -2, this is 0, 0, 0. Right? Now we need to write all the constraints. So what is the constraint here? First 3. The coefficient of x1 is 3. Coefficient of x2 -1. Coefficient of x3 2. Value of s1 here 1. x2 is 0. Sorry, s2 is 0. s3 is 0. Value, we got the initial basic feasible solution s1 is equal to 7. Like that we have to write all the constraints. Here the coefficient of x1 is -2, coefficient of x2 -4, the coefficient of x3 is 0 here, and s1 is 0, s2, value of s2 is 1, 0. Like that for the third one, -4, 3, x3 8, 0, 0, 1. The value of s2 12, value of s3 10. We have done with the table now. Just we need to write all the constant, coefficient of all the constant, coefficient of our objective function, then we need to solve it. As we all know, for the maximization case, to find the optimal solution, your Cj minus Zj for optimality. For maximization case, I am repeating once again, for maximization case, the Cj minus Zj should be less than equal to 0. And for minimization case, it should be greater than equal to 0. As we have converted the minimization to a maximization problem, so we are doing like our maximization problems. We are considering it as a maximization problem. At the last, we will decide the value of the minimization case. Let us see how we are doing. Zj, need to calculate Zj here. Zj we know how to calculate. 0 into 3 plus 0 into -2 plus 0 into -4. This is 0. This one is 0. This is 0, 0, 0, 0. This is also 0. As here S1, S2, S3, value is 0. How we are going to calculate the Cj minus Zj? Cj is -1 minus 0. -1 minus 0 minus 1. 3 minus 0, 3 minus 2 minus 0 minus 2, 0, 0, 0. So if you see here, the most positive number in maximization case, we consider the most positive number we enter our table. This is called the entering variable. Okay. This is the entering variable. So which one will be our living variable? This is our key column. This column is called the key column, right? So how we are going to find the minimum ratio? 7 minus 1. This is This we need to write 7 minus 1 minus 7. This one 12 divided by minus 4, that is minus 3. This one is 10 divided by 3. 10 divided by 3. So here we are not going to consider the negative value, only we have to consider the positive value. So this value will leave the column. This will be our minimum ratio. This is our leaving variable. In this case we are not going to consider the negative value. So this is our leaving variable. So what is our key element? The key element is minus this. This is leaving variable. This is entering variable. The intersection variable, that is 3 here. The intersection point is 3. This one called our key element. So as we all know, for our next table we need to keep this. We need to convert this key element as 1, and the corresponding value of the row, this is 0, and this we need to convert as 1, this one 0 and this one 0. So that row operation will be applicable for the all the values that exist in the row. Let us see how we are going to solve it for the next iteration. The first initial table we have completed, and we know that S3 is a leaving variable and X2 is a entering variable. So in the place of S3 I have written here X2, and the coefficient of X2 is 3 as we all know, and S3 will leave the table. This is our second simplex table. What we need to do? We need to convert the key element as 1 and what the corresponding value of the row, that the corresponding value in the row of the key. Actually the key, if the key element is here, this is our key element, we need to convert this was 1 and the corresponding row, the value of the corresponding row are 0 and 0. So let us see how we are going to do it. So to make the key element, as we all know, key element appeared in this column X2. So key element we need to convert to 1. So how we are going to convert the key element as 1? Our key element is 3. So R3 new, this one. Because here if you refer the previous table, the key element was this column here, X2, the third row, this row. This is 3. So how we need to make it 1? So R3 new, this is our new value, R3 new equal to R3 old. In our old table the value was 3. So 3 divided by 3 equal to 1. Let us write that value was 1. And we need to apply that row operation for the whole row. So we need to divide the whole row by 3. So let us write how we are going to refer the old table and write the value. Here we are having minus 4. So now we can write it minus 4 by 3. Here 3 by 3 equal to 1. Here what we need to write? Refer the old table. The value was 8. So 8 by 3. Here refer the old table. The value is 0. Because it is 0 in the old table. So 0. This is also 0. This is 1 by 3. And this value becomes 10 by 3. Done. For the second case, we need to make the value here 0, the corresponding row. value 0. So how we are going to make it 0? See, here we are having here minus 4. In the old table, if you see, the value is minus 4. So how we are going to convert it to 0? So I have written here R2 new equal to R2 old. R2 old, if you see, it is by plus 4. Sorry, minus 4 plus 4 into R3 new. R3 new is 1. 4 into 1 is 1. Minus 4 plus 4 is 0. So we can find here 0. In our old table, the value was minus 4. So if you write minus 4, we can write it like this: minus 4 plus 4 into R3 new. R3 new is our 1. So 1 minus 4 into 4, minus 4 plus 4 into 1. That is 4 equal to 0. So we can write 0 here. So that row operation will be applicable to the whole row. How we are going to do it? So if you write for our old table, the value was minus 2. So minus 2 plus 4 into minus 4 by 3. So what will be the value? Minus 22 by 3. This one 0. Then this one will be 32 by 3. Okay. This is 0. This will be 1. And this value will be 4 by 3. And this is 76 by 3. The whole row need to be, this formula will be applicable to the whole row R2. Now convert the R1. How we are going to convert the R1? So R1, if you see, R1 here we are having the minus 1. So if you see minus 1, in our old table it is minus 1. Minus 1 plus R3 new plus 1. Minus 1 plus 1 is 0. So this one becomes 0. So that rule will be applicable to the whole row. How we are going to write for this case? In our old table the value was 3. So 3, how it will be? 3 plus R3 new. R3 new is our minus 4 by 3. Minus 4 by 3. So what will be the value? 3 means it is 9. 9 minus 4 by 3, that is 5 by 3. So we can write here 5 by 3. Here we got 0. Like this, we have to apply for the whole row. So what will be our value? This is 14 by 3. H1 becomes 1. S2 becomes 0. And S3 becomes 1 by 3. And this value, if you see the old table, the value was 7. And this is converted to 31 by 3. Now find the ZJ. ZJ becomes this into 0, 0, 3 into minus 4 by 3. That is minus 4. 3 cancel, minus 4. This is 3. This one will be 8. This is 0, 0, 1. And this Z value becomes 10 here. In our previous table, we got the Z value as 0. This is, we are moving towards maximization. So this value is 10 now. So Cj minus Zj now need to calculate. Minus 1 minus 4. So this becomes minus 1 plus 4, that is 3. This one 3 minus 3, 0. Minus 2 minus 8, minus 6 here, sorry, minus 2, minus 6, minus 10 here, this value, minus 2, minus 8, this is minus 10, 0 minus 0, 0, 0 minus 0, 0, 0 minus 1. So, what is the most positive value here? If you see, this is our most positive value. This is our entering variable now. Entering variable. And what will be our leaving variable? This is our key column. This column becomes now our key column. This is our key column now. Right? We need to find the key element. This is our entering variable. So let us find how we are going to find the our leaving variable. This is 31 by 3 divided by 5 by 3. So this value becomes 31 by 5. This divided by this. So we are getting 31 by 5. Right? 76 by 3 divided by minus 22 by 3. That becomes minus 38 divided by 11. Here also 10 by 3 minus 4 by 3. This becomes minus 5 by 2. So these are negative values. No need to consider. In case of minimum ratio, we need to consider the positive value only. As we have here only one positive value. This is our leaving variable. So which will leave the table? S1 will now leave the table. What will come in place of S1? In place of S1, X1 will come to the table. And what is our key element? Now our key element is 5 by 3. Our key element is 5 by 3. So we need to convert this 5 by 3 to 1 in our next table. And these two values we need to convert it to 0. And that row operation will be applicable to the whole row. So let us see how we are going to do the next iteration. That is called the third iteration table. As it is a simplex table, the third simplex table we need to do to find our solution. Let us do it. So we have we have completed the second iteration table. This is our third simplex table. In our second simplex table, we got the key element as 5 by 3. So this was our key element 5 by 3. We need to convert the key element as key element as 1. That is what 5 by 3 into 1 and all the corresponding row value 0. We have to convert the key element to 1 and the corresponding row value to 0. Let us do it. This is 5 by 3. So how we need to do the row operation? I have written here. First, here in our old table it was 5 by 3. So how we are going to convert 5 by 3 to 1? So R1 new. This is our new R1 new. R1 new equal to R1 old. R1 old we are having 5 by 3. 5 by 3 divided by 5 by 3, this becomes 1. So we can write it 1 here. We need to refer the old table always to find the value of new table. So 5 by 3 divided by 5 by 3, this becomes 1. And this will be applicable to the whole row, means the whole row should be divided by 5 by 3. What we are having in our old table, the value 0. So 0 divided by 5 by 3 becomes 0. Old table it was 14 by 3. So 14 by 3 divided by 5 by 3. So this becomes 14 by 5. In our old table the value was here 1. So 1 divided by 5 by 3, it becomes 3 by 5. S2 was 0. 0 divided by something 0. And this is old table, it was 1 by 3. 1 by 3 divided by 5 by 3, that is 1 by 5. And this value becomes, we are having 31 by 3 and 31 by 3 divided by 5 by 3. This becomes 31 by 5. Like this we need to do it. For the second one, we need to convert this value as 0. So for that I have written here R2 new equal to R2 old. R2 old, the value was minus 22 by 3. So minus 22 by 3 plus 22 by 3 into 1. R3 new means this becomes 22 by 3 minus 22 by 3 plus 22 by 3. This becomes 0. So this row operation will be applicable to the whole row. So let us see how we are doing. First value was minus 22 by 3 minus 22 by 3 plus 22 by 3 into R3 new. R3 new value is our this is R1 new. This value is R1 new. Sorry, this is not R3 new, this is R1 new. Because our new value is R1 new here 1. So minus 22 by 3 plus 22 by 3 into R1 new, R1 1. So this becomes 0 here. In our old table if you refer, the value here 0. So 0 plus 22 by 3 into 0, this is 0. X3 value becomes, this one is 32 by 3, we are having 32 by 3. So this becomes 156 by 5. This value S1 value is 22 by 5. 22 by 5. This value is 1. This is 14 by 5. And this is 354 divided by 5. All will be in this form only, divided by 5 form. This is x2. For x2 I have written here, that is R3 new. This is our new table. So R3 new equal to R3 old. Old value was minus 4 by 3. So minus 4 by 3 plus 4 by 3 into 1. R1 new. Minus 4 by 3 plus 4 by 3, this becomes 0. And this will be applicable to the whole row. Means whole row, what is our R3 old? R3 old was 1. So 1 plus this one, 1 plus 4 by 3 into 0, that is 0. So this becomes 1. Right? So here the value is 32 by 5. This value becomes 4 by 5. This one is 0. This is 3 by 5. And this value is 58 by 5. 58 divided by 5. Okay. So now let us calculate the value of ZJ. ZJ minus 1. This is 0 plus 0. This becomes minus 1. This is minus 1, 0, 0. This becomes 3. This is minus 1. This is 0. This is 3 into 32 by 5. So this is minus 14 by 5, minus 14 by 5 plus 3 into 32 by 5. So this is minus 14 by 5 plus 96 by 5. So this becomes 82 by 5. 82 divided by 5. Here minus, this one is minus 3 by 5, minus 3 by 5 plus this is 0, 0 into 22 by 5 is 0 plus 3 into 4 by 5 plus 12 by 5. So this becomes 9 by 5. 9 by 5. So like this we have to do it. So this one will be 0, this one will be 8 by 5, and this becomes minus 1 into 30, 1 by 5 plus 0 plus 3 into 58 by 5. This becomes 143 divided by 5. Now calculate this one, Cj minus Zj. Cj is minus 1, minus 1, minus 1 means becomes plus 1, so this one will be 0. This is 3 minus 3, 0. This is minus 2 minus 82 by 5. Minus 2 minus 82 by 5. This becomes minus 92 by 5. This value 0 minus 9 by 5. 0 minus 9 by 5. So minus 9 by 5. This is 0. 0 minus 8 by 5 minus 8 by 5. So all the value here we got, that is Cj minus Zj. As we all know, Cj minus Zj should be less than equal to 0. Either the value we are getting here as 0 or less than equal to 0. So this solution is our optimal solution. So we have reached the optimal solution, and the value of Z here, maximize Z dash we have taken here, which is equal to 143 by 5, and the value of x1 equal to 31 by 5, value of x2 equal to 58 by 5. But this is a minimization problem. We have converted to a maximization problem. So what we have written here in the previous, if you refer, maximize Z dash equal to minimum of minus Z. So we have converted into minus to do this, and we have solved by maximization method. So now what will be our value? So our minimization of Z equal to minus 43 by 5, which is our optimal solution. So Z becomes minus 143 by 5. Here maximization we got plus 143 by 5. So we need to convert it to minus, because here only we have multiplied minus to the right hand side. So now our minimization Z equal to minus 143 by 5. If you solve it by minimization method, we have converted the minimization to maximization method. If you solve this minimization method by minimization method only, then also the value will come minus 143 by 5. You can try that one and check your solution. So this is our optimal solution. So we have completed the simplex method for the minimization case. Now I hope you understood the video. Please share this video with all your friends and do subscribe the channel. Thank you so much.